Exploring the periodic table. For this section, you need to read pages 151 to 155 and answer questions 1 through 8 on page 155. So the objective here is to understand why elements within a group on the periodic table have similar characteristic properties. The reason why they do is because they have the same number of valence electrons. So let's talk about what the group is. The group, of course, is the column that it's in. And we're not really talking about groups 3 through 12 right now. They're similar, but they're similar all together. We're talking about group 1, group 2, 13, 14, 15, 16, 17, and group 18 are the groups that we're talking about. Remember, the groups are the columns, the row is the period. Okay, and the group relates to the number of valence electrons. So the valence electrons, those are electrons in the outer energy level. We talked about that last chapter, and it causes the periodic trend on the periodic table. All atoms want to have a full outer shell of electrons, so they gain or lose electrons to accomplish that. When they gain or lose electrons, they form what's called an ion, which is a charged atom. If electrons are gained, since electrons have a negative charge, and now there's more electrons than protons, they have more negative charges, so gaining electrons gives you a negative charge. Losing electrons now gives you more protons than electrons, and so you have a positive charge. So let's talk about the individual groups. Let me move this up a little bit. Group 1 elements, which would be these here: hydrogen, lithium, sodium, potassium, and so on. Group 1 elements, they have one outer shell electron, and so they have a tendency to lose that to form a positive ion. So most of these will form only a +1 charge. Since they have one outer shell electron, they've got a tendency to be very reactive. They want to get rid of that electron, so they react with almost anything. Group 2 elements, which would be the group right beside group 1, beryllium, magnesium, calcium, and so on. These have, since they're in group 2, they've got 2 valence electrons. So they've got a tendency to lose those 2. It's easier to lose 2 than it is to gain 6. Same thing up here with group 1. It's easier to lose the 1 than it is to gain 7. So they've got a tendency to lose their electrons. And since they now lose 2, they have a +2 charge. They've got 2 more protons than they have electrons. Group 2 elements, since they've got more electrons to lose, they have a tendency to be a little bit more stable than the group 1 elements. They still want to form compounds, but they can be found as that element in nature. Group 1 elements almost never are found in nature as pure elements. They're almost always found as part of a compound. Now let's go to the other side of the periodic table, group 17 elements. So group 17 elements would be fluorine, chlorine, bromine, iodine, and so on. This group right here. They have 7 outer shell electrons, so they have a tendency to gain 1 to have 8. And so they form a negative ion since they've got 1 more electron than they have protons. These, just like the group 1 elements, are extremely reactive. And they form bonds very, 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 very readily. A little bit about classifying elements. On the periodic table, normally what we say, anything on the left-hand side of this stair-step line here, across here, these are metals. Anything to the right of the stair-step line, these are nonmetals. Anything that's touching the stair-step line, for the most part, not everything, aluminum would be an exception, is what we call a semiconductor. Sometimes you'll see them as metalloids. So let's talk about each of these metals. They have a tendency to conduct electricity and heat. Nonmetals don't conduct heat or electricity very well. Most of them are found on the right side of the periodic table, which we talked about. The semiconductors, they share properties of both metals and nonmetals, and they're found on the dividing line between metals and nonmetals.